Imagine looking up at the night sky, billions of stars, countless galaxies, a universe that feels eternal. It seems impossible to imagine it ever coming to an end. But what if the universe doesn't end in fire or collapse into darkness? What if it simply pulls itself apart, not in an instant, but piece by piece, galaxy by galaxy, star by star, planet by planet, until nothing remains? This terrifying possibility has a name: the Big Rip. According to one theory, the same mysterious force that's causing the universe to expand could eventually become so powerful that nothing can resist it. Not gravity, not stars, not planets, not even atoms. Right now, the universe is already expanding. Every distant galaxy is moving farther away from every other galaxy. And surprisingly, that expansion isn't slowing down. It's accelerating. Scientists believe an invisible force known as dark energy may be responsible. It makes up nearly 68% of the entire universe, yet we still don't know what it really is. If dark energy remains constant, the universe may continue expanding forever. But if it grows stronger over time, everything changes. The expansion would no longer simply separate galaxies. It would begin to overcome every force that holds the universe together. Gravity would lose. Then the forces binding stars. Then the forces holding planets in orbit. And finally, the forces holding matter itself together. The universe wouldn't explode. It would slowly unravel, like a thread being pulled from a sweater, until nothing recognizable remained. Could this really happen? Is the universe already moving toward this extraordinary fate? And if so, when would the first signs appear? To answer that, we first need to understand what the Big Rip actually is. So, what exactly is the Big Rip? At first, it sounds like the title of a disaster movie, but it's actually one of the most fascinating ideas in modern cosmology. To understand it, we first need to remember something surprising. The universe isn't expanding because galaxies are flying through space. Space itself is expanding. Imagine drawing dots on the surface of a balloon. As you inflate the balloon, every dot moves farther away from every other dot. Not because the dots are moving, but because the surface between them is stretching. That's exactly what's happening across the universe. For billions of years, gravity fought against that expansion. It pulled galaxies together, built galaxy clusters. It created stars, planets, and ultimately, us. Then came one of the biggest surprises in astronomy. Scientists discovered that the expansion wasn't slowing down. It was accelerating. Something stronger than gravity was pushing the universe apart. That mysterious force became known as dark energy. Now imagine that dark energy doesn't remain constant. Imagine it grows stronger and stronger over time. At first, nothing unusual would happen. Galaxies would simply drift apart a little faster. But eventually, dark energy would become powerful enough to defeat gravity itself. Galaxy clusters would no longer remain bound. Then individual galaxies would begin to fall apart. Later, solar systems, then planets, and finally, atoms. This chain of events is what scientists call the Big Rip. It's not a giant explosion. It's not a collision. It's the gradual victory of expansion over every force that holds the universe together. The fabric of space would stretch so violently that nothing could remain connected. Every structure in the cosmos, from the largest galaxy clusters to the tiniest particles, would eventually be torn apart. But would this happen all at once? Not at all. The Big Rip would unfold in stages, and the first victims would be the galaxies themselves. If the Big Rip is real, the end wouldn't begin with Earth. It wouldn't even begin with the Milky Way. It would begin on the largest scales imaginable, the galaxies. Today, gravity keeps galaxies bound together. Billions of stars orbit their galactic centers. Some galaxies even orbit one another, like our own Milky Way and the Andromeda Galaxy. In about 4.5 billion years, those two galaxies are expected to collide and merge. But in the Big Rip scenario, that future may never happen. As dark energy grows stronger, its repulsive effect would eventually overpower gravity. Galaxy clusters, the largest gravitationally bound structures in the universe, would be the first to break apart. Galaxies that had spent billions of years traveling together would begin drifting away forever. Then the galaxies themselves would no longer survive. The invisible halo of dark matter holding them together would no longer be enough. Stars near the outer edges would escape first. Then more and more would follow. Slowly, the graceful spiral arms would unravel. The brilliant galaxies we see today would lose their shape, until nothing remained but isolated stars racing away through an ever-expanding universe. Imagine looking into the night sky billions of years from now. Today, we can see countless distant galaxies. But one day, every galaxy beyond our own could disappear beyond the observable universe. Not because they stopped existing, but because space expanded too quickly for their light to ever reach us again. The universe would become darker, quieter, lonelier. Eventually, the Milky Way itself would stand alone, surrounded by an endless darkness where billions of galaxies once filled the sky. But the Big Rip wouldn't stop there, because once galaxies could no longer resist the expansion, the next victims would be something much closer to home, our own solar system. After galaxies begin to fall apart, the Big Rip moves closer to home, much closer. For billions of years, gravity has kept our solar system in perfect balance. The Sun holds Earth in its orbit. Earth holds the Moon. Every planet follows its path with astonishing precision. It feels permanent, unbreakable. But if dark energy continues growing stronger, even gravity will eventually lose. At first, nothing changes. The planets continue orbiting the Sun. Life carries on. Then, the invisible force stretching the universe becomes stronger than the Sun's gravity. Earth begins to drift. Mercury, Venus, Mars, one by one. The planets escape their orbits. The solar system, which remained stable for billions of years, starts to unravel. Imagine looking up at the night sky. The familiar constellations are gone. The planets no longer follow predictable paths. The Sun grows smaller as Earth drifts away into interstellar darkness. There is no collision, no explosion, just an ever-growing distance, a silent separation. Eventually, even the Moon can no longer remain bound to Earth. It slowly drifts away, disappearing into the darkness. By now, the solar system no longer exists, not because it was destroyed, but because the force of expansion became stronger than gravity itself. It's a haunting thought. The same force currently stretching the universe could one day pull apart the very system that gave birth to us. But the Big Rip still isn't finished, because if gravity can no longer hold planets together, what happens when the expansion becomes stronger than the forces holding matter itself together? That's when the most terrifying stage begins, the end of atoms. For most of human history, we feared that the universe would end in fire or collapse into darkness. But the Big Rip offers something even more unsettling.
Rewrite the laws of physics. You wouldn't even know it had begun until it was already upon you.
Separation. And one by one, galaxies disappear, then stars, then planets, then atoms, until nothing remains connected to anything else. It's a haunting idea, not because it's violent, but because it's silent. The universe doesn't scream. It simply grows emptier, lonelier, colder. Every second, space stretches a little more. Every second, distant galaxies move farther away. For now, gravity is still winning where it matters most. It holds galaxies together. It keeps Earth in orbit around the sun. It keeps the atoms in your body intact. But on the largest scales, dark energy is already changing the universe. Whether that story ends with the Big Rip or with another cosmic fate remains one of the greatest unanswered questions in science. Perhaps the universe will expand forever. Perhaps it will slowly fade into darkness. Or perhaps, one day, every structure in existence will simply come apart. The truth is, we don't know. And that's what makes cosmology so extraordinary. Every new telescope, every new discovery, every new observation brings us one step closer to understanding how the universe began and how it may one day end. Until then, the Big Rip remains a powerful reminder that the greatest mysteries aren't hidden inside black holes or beyond distant galaxies. They are woven into the very fabric of the universe itself. Because in the end, the biggest mystery isn't when the universe will end, it's how. And somewhere, billions of light years away, the answer may already be written in the expansion of space itself.